Alright, number 9 says, use the definition of continuity to find the values of k and or m that will make the function continuous everywhere. Our function is g of x. Our focal points that we should be looking at is, I'm approaching 2 from the right, and I'm also approaching 2 from the left. So the first focal point is x is equal to 2. I'm also approaching negative 1 from the right and negative 1 from the left. So our second focal point is x is equal to negative 1. Okay? You should identify around here that you're going to have 2 sets of proofs as far as the 3 rules for each one. So let's go ahead and work with the 2 first. Okay? So we're making it continuous everywhere. Means again, our 3 rules must be true, and they rule 2 and 3 3 should say that rule 1 and 2 equal each other. Alright, so let's find f of 2. F of 2 is defined, and we're going to say that f of 2 is equal to whatever my equals 2 function is going to be, which in this case is right here. Plugging that in, we get m times 5 plus k. So we could say f of 2 is equal to 5m plus k. Alright, so now let's go to the actual limit. Rule 2 says that the limit will exist. So the limit of g of x exists, and this is when I approach 2 from the left and right. There's the general limit. So real quick, let's diagnose as far as what the left and right are looking like individually. Alright, so the limit of g of x as x is approaching 2 from the left is equal to the limit of g of x as x approaches 2 from the right. Because again, we're working backwards. We're basically working from rule 3 backwards, and then we're solving for k and m. Alright, so let's see if I approach 2 from the left, which in this case is going to be using this equation. If I approach 2, it's still going to be the same equation that you saw up here, 5m plus k. But if I approach 2 from the right, I'm going to actually use, because of this domain, this function. Plugging in 2, you get 2 squared is 4, plus 5 is 9. So there's our first equation of our systems of equations that we're going to have. You should identify that you're going to have systems of equations when you have 2 focal points, and you're going to use those 2 set-ups as far as the equation that you get. Like this is the first one. You're going to use it to find the variables m and k. Alright, so rule 3 we'll get to here in just a bit. What I want to do is I want to set up the rules for the other focal point. Alright, so let's go back just a little bit. And we're going to now concentrate on this negative 1 focal point. Alright, so rule 1, f of negative 1 is defined. And if I go to my piecewise function and I identify where negative 1 would be equal to domain-wise, we're going to see that we're going to use the third equation. F of negative 1, we're just trying to find a y output. If you don't have your calculator, synthetic division can be used. 2, 0 for the x squared term, 1, 7, and you can put negative 1 to find out what is the y value here. So you get 2, negative 2, negative 2. Remember, just copy that down, then multiply. Then we add, then we get positive 2. We add to get 3, negative 3, we get 4. So f of negative 1 is equal to 4. Now we're going to go to rule 2. Rule 2 shows, again, that the limit does exist. So the limit of g of x exists. This time as I'm approaching negative 1. Okay, as I'm approaching negative 1, again, just like I did on the other part, I'm going to have 2 one-sided limits. I'm going to have this one approaching from the left, from the right, and this one approaching from the left. So if I put in this left-sided limit, the limit of g of x as x is approaching negative 1 from the left, I'm going to use this one right here, which if I put the negative 1, we remember that we got an answer of 4. Okay? And then I'm going to go to the other one. Remember, just like we did on the other example, we're just breaking up this general limit into two one-sided specific limits. So if I looked at approaching -1 from the right of this g of x, I'm now going to use this one. This is approaching from the right. So let's put in -1 for our x value. So -1 will be inputted here. Plus 3 is 2, so you have 2m plus k. This is our other equation. These will equal each other because, again, we're working backwards from rule 3. So if we line these up, we could have 2m plus k is equal to 4. Alright? And we can put rule 3 on both of these. We'll put the limit of g of x as x is approaching 2 is equal to f of 2. And over here we'll put the limit of g of x as x is approaching -1 is equal to f of -1. Now we just have to solve for m and k. Because then, therefore, we're saying g of x would be continuous is then continuous everywhere. Alright, so let's solve the systems of equations. I'm going to go to multiply this bottom piece by -1. I'm doing the elimination method as far as systems of equations. System of equations, I'll have a -2m minus k is equal to -4. And all we're going to now do is add these up so that the k's cancel out to 0. And you're left with 3m is equal to 5. M is therefore equal to 5/3. We just got one of our pieces that we were looking for. M is equal to 5/3. Now we can use this m to plug in back into any one of these two equations to get k. Let's use the first one. So if I plug it in, I'm going to say 5 times 5/3 is going to be 25/3 plus k is equal to 9. So if I subtract, I'll get k is equal to 9 minus 25/3. Change 9 to 27/3, common denominator, and I'm going to get k is equal to 2/3. And there is all your work and answers.